Okay, so with this section and a lot of the sections that follow here, we're going to be going over different ways to prove that triangles are congruent. So the lesson today is proving triangles are congruent by side, side, side. So there's a handful of different rules that we'll be getting into. This is the first of them. So for side, 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 it essentially means that if you have a side congruent to another side, and then a second side congruent to the second side, and our third side congruent to the third side, then we also know that the two triangles are going to be congruent. So by knowing those sides, we also know that the angles involved are going to be congruent. So we know that A, B, and C would be congruent to R, S, T. So again, so simply just prove our side, 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 or as it'll normally be written, SSS. So if you can prove side, side, side congruence, you know that your triangles are congruent. Okay, so you could see an example like example 1, a kind of simple version of a proof here, something we still might see here. Are given. So we have KL is congruent to NL. So KL to NL, and you can see our one line there to represent the congruence. We also have given our KM is congruent to NM. Okay, so KM is congruent to NM, and that's our two lines. And so we're just trying to go ahead and prove that these two triangles are congruent. So all we have left in the middle here is LM congruent to LM, obviously by the reflexive property. So we know that those two triangles are congruent now by the side, side, side congruence postulate. So triangle KLM is congruent to triangle NLM. Okay, for example 2, this is the type of problem you'll see on a standardized test practice, which is why they have it labeled like that here. Okay, so which are the coordinates of the vertices of a triangle congruent to triangle PQR? We can go in here. It's pretty easy to find PQ. We can just count off the units here. So 1, 2, 3, 4. So we have 4 there. We have 1, 2, 3 here. So let me switch over here. Okay, so we have 4. We have 3. Now they go through all the steps here using the distance formula. I don't know that that's necessary. Hopefully you guys paid attention in Algebra 1 and you know that once we have 3 here and we have 4 here, this is our nice little perfect triangle here. So we can come back in and we know this is 5. If you don't know that and you want to go through all the steps, you can go back up and do that. Okay, so then we have our multiple choice over here. So you can go back in. If you look at letter A, you can see here that we have -1, 1, -1, 5. So the distance from those, we have the same x value here. So we can just go look at the y value here. That's going to be 4. So switch back over to my pen here. Okay, so we have our first side is going to be 4. And then we can go back in. We have our 5 here. Here, let me switch back. Okay, so we have our 5 here, both in our y values. So we could just look at the -1 and the -4. So that distance there is going to be 3. So this one's looking pretty good right now. And then we can go through and we can do the rest of the steps here. So you go back and put the last part into the distance formula here. So we put in our 5 minus 1 squared plus -4 minus -1 squared. We work that out, and square root of all of that. work that out. So we have the square root of 4 squared plus negative 3 squared. So 4 squared 16 plus negative 3 squared, that's going to be 9. So square root of 25, that gives us our 5. So our last side here is going to be 5. And don't you love it on a multiple choice when the answer is A, because we don't need to go through the other ones. So the answer is A. That's the congruent triangle to triangle PQR. Okay, and the last example for another nice short section here is example 3. This is a nice real-world problem here. So what it's saying is explain why the bench with the diagonal support is stable. So the diagonal support right here, while the one without the support can collapse. So this one's pretty straightforward. So by the side-side-side congruence postulate, these triangles cannot change shape. So we have our congruent sides, and then by reflexive property, our last congruent side, the diagonal here. So we know that those cannot change shape. Then we have the bench over here, which does not have a diagonal support. So that one has many different quadrilaterals that you can form in here. So that one is not as stable.